everyone. I hope my screen is visible. Guess the camera is a bit off. Just wait a second. Hi, hello everyone. Welcome to today's live. I'm Aditi, your physics faculty, and today we are here for the live of our chapter Electricity. Hi, legend. You are first. Just give me 1 second. We'll wait for all of the children, all of the students to join. Okay. Good morning, legend. Am I audible? And is my audio and video clear? Okay, let me know if I'm audible and visible. Today's live, we will be seeing the chapter Electricity, and we'll start with the revision. We'll start with mind map, and then we'll move on to the numericals. And I've got you some pretty good numericals today. Hello? Can you send Akash? So we'll be doing, I've got you some really great questions as well as numericals. Majorly we'll focus on numericals as this chapter is heavily numerical based and not just the theory. So we'll start with the revision. Your name, ma'am? Ma'am, my name is Aditi. Ma'am, my name is Aditi and I'm your physics teacher. Today we'll start with the... वो camera सही नहीं है.
He's not there. I'm waiting, I said.
Okay, so can we start? We'll start with the mind map. We'll do the revision or focus on all the concepts, all the theory that we need to do to solve those numericals, okay? And then we'll move on to the numerical part. Okay, let us start this session. Let us start with the live. The first thing I've got you is a very great mind map. Okay, so mind maps are basically we will use for revision. So electricity, what is, when you think of electricity, what is the first thing that comes into your mind? Ma'am, electricity is related to charges and currents. So charge is a basic property of a matter or a conductor, we can say, or a body. We can say it has some atoms, ions, electrons. Due to that, a charge is produced in this body. When this charge moves, we get current. So current is motion of charges, correct? Now, based on this charge and current, one of the most important concept of this chapter comes into play, that is Ohm's law. So the first thing we'll study in this chapter, that will be Ohm's law. Is it clear to you guys? Can I zoom it? The camera is not aligned. So we'll start with what? We'll start with Ohm's law. So the most important basic thing is, yes, legend, you are correct. Current is flow of charges. Very good. So the basic thing we need for this chapter is Ohm's law, which is nothing but a relationship between potential difference and current flowing through a conductor at constant temperature. At all times you have to mention that it's constant temperature. Hello Dilip. Hi Sonu. Hi everyone. So we have started the revision of the chapter electricity and then we'll move on to the numericals. Again, I want to mention numericals are really great this time. Okay, can we move to the okay, so started with Ohm's law. Done with Ohm's law, we can then move to what? Ohm's law is done. Moving on to what Ohm's law described us, that V is directly proportional to I, but when we take out the proportionality constant, we put a constant that is R. R is resistance, correct? R is resistance, my friend, and R is, due to this R, we have a property of the material that is resistivity. So to study resistivity, it is related to the resistance, which is, oh, what is this formula? Okay, so rho is basically, see, resistance is basically rho L by A, correct? So from here, rho will become R into A divided by L. Yeah, so here we'll just have the formula as L. Yeah, correct? Understood? So we have studied Ohm's law and we have revised resistivity. Now moving on from Ohm's law and resistivity to power, or see, this is the electric current we studied. Everything that you want, that you can get for the electricity is in this slide. So take care of this slide very, very efficiently. You have to focus on this. Okay, so we have studied Ohm's law, we have studied electric current, which is nothing but rate of change of charges. So I equals to Q by T or Q equals to IT. And to study all this, we'll move on to all the other topics. Before that, I want to show you some of the basics that you need to remember for this chapter, just basic symbols. So this is my resistance, okay, this is rheostat, this is resistance, rheostat, a resistor. You should know the basic difference between these, okay? Wire crossing, if the wire is crossing something like this, that means these two wires, the green wire and the red wire, are not touching each other. Then this is a wire joint, that means the wire is touching each other. And a cell, dry cell, bulb, switch wire and fuse wire, correct? All these basic things are done. Now this is my basic electric circuit. What happens is, for this basic electrical circuit, we have a battery, we have a bulb that we are using, correct? And we have an ammeter to measure the current that is there in this circuit, correct? And then we have a key to plug in this, just a minute, yeah, to plug in this circuit. If I plug in the key, current will flow in the circuit. If I plug out the key, the current will stop flowing in the circuit, correct? That is done for electrical circuit. So we are done with Ohm's law, all the basic symbols and circuit, current and resistivity, correct? These are some of the basic things that you need to remember for the chapter electricity, correct? Now moving on to some of the topics. This resistance we have studied, okay? Leading from Ohm's law, we have V, I, R. Now we need power, because power is the thing that we need to glow our bulbs, okay? Power decides how much brightness will go into the bulb, and again that will also lead to heating effect of current and all, correct? But power is a very important topic. So power will see power. See, this is the power. So power is nothing but the and current that is flowing in our circuit, that is flowing in our conductor. Okay, so the formula is basically rate at which electrical energy is dissipated, we can say. So potential difference into current, that is the product. And if I use Ohm's law, that is V equals to IR, I'll just put IR in this, I will get V square by R formula, and in the form of potential difference, I'll get V square divided by R formula. In current, I will get I square R formula. Correct? Done with Ohm's law, potential difference, resistance and power now. Correct. Moving on to the next thing, which is potential, or okay, so just a minute. So these are the basic things. One more thing is that is electrical energy. So electrical energy is nothing but power into time. Correct. The power that is being flown in our circuit, the power that is dissipated in our circuit, electrical energy is the product of power into time. Correct. Now some of the factors on which these all things depend. Correct. So on electric potential or potential difference is thus dependent on, now okay, not electric potential, resistance. Resistance we have studied, right? So resistance is rho L by is dependent on length of the conductor, area of cross section of the conductor, and resistivity of that material or nature of that material. Correct. Understood. Now this potential difference, what is exactly potential difference? Potential difference is the work done to move a charge from one point to another. In this particular 10th class, we are studying that a charge, sometimes we study the charge that is being moved from infinity to a particular point, okay, and both of these are almost same. So potential difference is nothing but the work done to move a charge from one point to the another. Correct. Then some of the dangers of mishandling electrical appliances, we know this is electrical shock, explosions happens due to overloading or short circuit. Correct. When the fuse melts, fuse helps us to prevent all these shocks and fires, etc. Correct. So this basically was overall our chapter. Now one important thing that is left is what? It is the resistance formula. It is very important for your numericals, very important for your board exams. That is, for this is basic Ohm's law, we know that, correct? So in parallel combination, this will be my resistor for the combination or equivalent resistance formula, which is 1 by R1 plus 1 by R2 plus 1 by R3. For series, on the other hand, the total or equivalent resistance will sim of electric current or Joule's law of heating. That is H equals to I square RT. Correct. Heating effect of electric current depends on the square of current into resistance into time. Correct. So that is I square RT. Correct. And you can also write VIT in the form of potential difference and okay, wait a minute. Is it still the same? You're saying screen is lagging. Is it still the same, guys? It's let me know, please. Is it still the same? Just give me a minute, okay? Hello. Okay, it's good now, right? Okay, it's working now, right? Okay, let's resume our lecture. The only thing that was left for our chapter is heating effect of electric current, that is I square RT. And with this, we have quickly revised our chapter in, I don't think, in what, 14-15 minutes, I guess. Okay, so the whole chapter of, you can take a screenshot if you want, and you can just revise this and you'll be done with your boards. Correct? Okay, now moving on to our questions, which is very important for this particular chapter. First question, we will start with the very basic, very first question, that is, when electric current is passed, electrons move from potential to low potential, to then move from low potential to high potential in the direction, to then move from low potential to high potential in the direction of current or against the direction of current. When the electric current is passed, again, okay guys, we are sorting it, just give us 1 or 2 minutes. Hello. Hi everyone. Is the connection all right now? It's not lagging now, right? Just let me know once so that we can resume our class. Yes, hi Vishnu Priya. Okay, it's fine right now. I चल रहा है. Okay, hi everyone. So really sorry for this, maybe that was some internet issue, I guess. Okay, resuming, we just revised our whole electricity chapter in just 14-15 minutes, I'm guessing. So moving on to the questions which are very important. These are PYQs, most expected questions, and will be very important for your boards. So be very careful while attempting this. I want you to have your pen and paper with you because we are going to do some really great numericals today. Okay, the first question will be starting with, when electric current is passed, electrons move from where? High potential to low potential, low to high in the direction of current or opposite to the direction of current. Be very careful. This we are talking about electric current. Electric current and electric charges are very different thing. Okay, Anirudh is saying D option. Okay, let us check. Anirudh is saying D, yes. Okay, yes, I saw your answer. See, D option is against the direction of current. Okay, they are asking that electrons move from when electric current is passing. So this is very simple. This is my electric current. So electrons definitely go against the direction of current. So Anirudh is correct. First option, first answer D is very correct. Actually it's D. When electric current is passed, electrons, they have asked about electrons move from against the direction of current. Correct? Okay, moving on to the next option. Yeah, I can see why you guys are saying low potential to high potential. Okay, that is also can be a correct option, but when you are given electric current, that means they have asked in significance, in reference to electric current, so you can answer against the direction of current. Okay, next question says, read very carefully, a cell, this is again a very simple but very important question for your concepts. A cell, a resistor, a key and emitter are arranged as shown in the circuit diagram. Correct? Figure 1, 2, 3. The current recorded in the emitter, will the current be maximum in 1, in 2, in 3, or will it be same in all cases? Yes, legend, I know why you are answering B, but in reference to electric current, if they have asked, then you can answer in the opposite direction of the electric current. Okay. Okay, now let me know the answer of this question. A cell, a resistor, all these are connected in a series, and they are asking if the current is maximum in one of these cases or same in all cases. Okay, so Anirudh is saying D, A, Vishnu is saying D. Okay, okay, let's see what is exactly happening here. So in this circuit, if you look closely, everything is almost similar. The emitter is connected in series with the resistance key, and then again the emitter is connected in series with the resistance, and here again emitter is connected in series with the resistance. Correct? Now since they all are in series, and if we assume, or if they have given they have equal voltage, then current will, because R is same, correct? R is also same. It doesn't matter if the key is connected first or the emitter is connected first, all these are connected in series, and in series current remains the same. Correct? Next question. Now very good question starts. If length of wire is increased by 20% by stretching. So we had a wire, correct? This is my wire. We increased its length by stretching. This stretching word is very important. By stretching, change its resistance and resistivity. Calculate the change in resistance and its resistivity. Okay, calculate the percentage change in its resistivity and resistance. Again, now the screen is not posing, right? This is fine. For me, it's fine. Yeah, D option was correct. Legend Vishnu, D was correct. Now, I asked you to get a pen and paper. Solve this question because it's very important. If length of wire is increased by 20% by stretching, we have to calculate its change in resistance and resistivity. This is just some garbage text. We have to calculate change in resistance and resistivity. Can you guys solve this? And meanwhile you are solving it, like this session first, because we have done the revision, we have done 2 questions, we are on the 3rd one. So like this session if you are learning something from it. Okay? Okay. Let me know if you are solving it or not, because it's very easy and it's a very good question, something that requires a little bit of brain. Okay. So this was my original length, let's say L1, that was L, and original area of cross section A1 equals to A. I'll take the new length as L2 and we'll see what it comes, and A2, and we'll also see what this one comes. Hi Shubham. Okay. Okay Shubham, I want you to solve this question. Now, what is happening? They are saying that we stretched this. Now, why I am stressing so much on this word stretched? Because if you stretch a wire, its length increases, correct? But its area of cross section also decreases, correct? And that is a very important point. Now, we need to calculate change in resistance, let's say first. So, resistance is what? Rho L divided by A. Correct? For R1, for length of the, okay, so R1 will be rho L1 divided by A1. Correct? So R1 will be rho into L divided by A. So that means this L1, correct? So this will be L plus 20 to L, that will be 1.2 L. Correct? Now, since the wire is stretched, its area of cross section will decrease. And how much it will decrease? It will simply decrease by this particular amount, by which the length is increasing, the area will decrease by that same amount. Correct? We have studied this in previous questions as well. Okay, so we'll see R1. R1 is simply rho L by A. So R2, now R2 will be rho into 1.2 into L, correct, divided by A divided by 1.2. Understand? Now if I'll just solve this, this will be rho L by A. This will go above and it will become 1.44, correct? So this is my new R2 and this was my previous R1 before stretching, after stretching. Now we have to calculate percentage change, correct? Percentage change in resistance. So that will be what? R2 minus R1 divided by R1 into 100. That will give the percentage change of resistance, correct? So percentage change will then be R2 is 1.44. Can I write this as R? Correct? So R2 is simply 1.44 into R and R1 is simply R. Correct? So percentage change will be 1.44 R minus R divided by R into 100. Correct? Now if you solve this, I'm solving it here. If you solve this, you will get 0.44 into 100 and you will get 44%. So the percentage change in R will be 44%. Correct? Understood, everyone? Now, of course, legend legend has said 44% and yes, legend has also said that percentage change in resistivity will be 0%. That is 100% true, as the material is same, the wire is same and resistivity is a property of material, is a property of that particular wire, and for that single wire resistivity won't change. Correct? Okay. Let's move on to the next question, that is fourth question. Just as electricity is supplied at 220 volt for domestic use in India, it is supplied at 110 volt in USA. So we know at our homes we get voltage as 220 volt, correct? We get the voltage of 220 volt, but in USA they get the voltage as 110 volt, correct? Now they are asking if the resistance of 60 watt bulb, so a bulb is there whose power is given as 60 watt, if the resistance of 60 watt bulb for use in India is R. We have the resistance in India as R, correct? But then they are asking then that of a 60 watt bulb for use in India in USA will be. So they are asking for the same bulb of power 60 watt, what will be the resistance in USA? Anirudh is saying B. Amit Shah is saying hello. Hello, Amit Shah. Okay. Okay, Anirudh also gave the answer as 44%. Very good. Okay. Let's see the solution of this particular question. Very good question. Now, what we need is we have power. So, power for both India and USA is same. Correct? Power for both of them is same. So, can I write power in India equals to power in USA? Correct? Because the bulb is taking out the same power, which is 60 watt. For power, the formula is what? V square divided by R. Correct? That means 220 square divided by R. Good. For USA, if we apply the same formula, formula does remains same in India and USA. So the resistance we need to find. This is we need to find the resistance for the bulb that we are using in USA for the same power. Correct? Now if these powers are equal, I can just equate these formulas, that is 220 square divided by r equals to 110 square divided by r USA. This is a given quantity. R is a given quantity, but R USA is something that we need to find. So this 220, if I can just not cross it, 2 it remains. If you just open it, 220 into 220 equals to 110 into 110 divided by R USA divided by R. So they will cancel this as 2 and 2. So this will be 4 divided by R equals to 1 by R of USA. Correct? Is this correct or not? Hi Shubham. Let me know, everyone. Everyone is saying option B. Oh yes, we have to cancel these squares. Correct. These squares will get cancelled out. Just let me see. Yeah, so here we can cancel these squares out, but they have R down there. The whole power, the whole equation is not inside these squares, correct? So anyway, you can do it in any way. So if you get this 220 divided by 110 whole square equals to R by R US, then you will get 2 and this will be 4 equals to R by R US. Now if you just switch it, you will get R US equals to R by 4. Correct? The answer will be R by 4. Everyone understood or not? Answer will be A, R by 4, because we have square, guys. Correct? Yes, the answer will be A. Okay, moving on to the next question, that is our fifth question. Again, I'm telling you, I've got you some really great numericals, so do get ahead of this. You can solve these numericals and you can get ahead of lots of people. Okay, what is the equivalent resistance across A and B? These are the 2 points given, that is A and B, if R equals to 3 ohm. All these circuits, the R is given as 3 ohm. Can you guys solve this? Can you guys solve these questions? No, the squares won't get cancelled. We don't have the whole powers. If R and R square would have been also inside the squares, then we could have cancelled them. But these are constant quantities. Of course, how will you, that doesn't make sense, right? 220 divided by 110, 220 square divided by 110 square. So if they get cancelled, 2 will come, then you will have to square them. Even if you just see, that is 220 into 220 equals to 110 into 110. It is something like this, right? So how can you cancel the squares? Okay. Can you solve this equation? They are saying, Anirudh is saying, answer as B, that is 15 ohm. Okay. Okay, let's solve this particular question. B, you are saying 15 ohm. Okay, let's see. There is also an option here that is none of the above. Let's see what comes. So, if you look at this circuit carefully, what are the first resistances that you will pick to solve? The ones which are very easy to solve, of course. Now, you cannot take this one because this whole part also has another sub part. So what you will do, you will take these two particular wires. Correct? These two particular wires are in series. These two resistances are in series. Let's just name them 1, 2, 3, 4 and 5. Correct? So these two are in series. So R1, 2 will become R plus R, that is 2R. Correct? Now this whole, what will this become? This will become something like this. Something like this. Now this is R and this is 2R. Correct? And this is the rest of the circuit. A, B. Correct? Now these two are in parallel. So to solve this is R3 and R12. To solve this, you can write R312, that is 1 by R3 plus 1 by R12. Correct? Now 1 by R3 is simply 1 by R plus 1 by R is 1 by 2R. Correct? And if you'll just take the LCM, this will be 2 plus 1. This will come out to be 3 by 2R, but this is 1 by R312. So R312 will become R312 will become 2 by 3R. Correct? So this whole circuit becomes 2 by 3R. Now the circuit becomes this A, B, and we have two resistances, this one resistance and this one resistance. This is 2 by 3R, this is R and this is R. Correct? Now these three are in series, so we can simply add these. That will be R plus 2 by 3R, which will be 6 plus 2 by 3R. That will be 8 by 3 into R. Now since R is given as 3 ohm, you can just substitute the value of R. 8 into 3 divide by 3, and this answer will be 8 ohm. Answer will be what? It will be 8 ohm. And we don't have any option as 8 ohm. So the answer will be, how are you guys answering B? Legend did say none of the above. Death Gamer said A. Okay, so the answer, Legend, is actually correct. Legend is actually a legend. His answer or her answer was correct. That will be none of the above. Correct? Okay, moving on to the next question. Bulbs in the given figure are something like this. We have 1, 2, 3, 4, 5 bulbs in a given circuit. Okay, which bulbs lights most brightly? Among which of these bulbs will have the most brightness? Sorry ma'am, my option is incorrect. It's fine, Anirudh. Your option was actually correct. D, no? Okay, for the next question, D. Everyone is saying D. Okay, you guys are really, really smart. I am seeing. Vishnu, Amit, Anirudh, everyone is saying D. Shivam is also saying D. Yeah. Okay, so basically you don't even have to solve this question. You just have to see what is happening. For the bulbs to light up, the main phenomena is heating effect of electric current. That is H equals to I square RT. Correct? Now we just have to see in which of these bulbs are getting maximum current. Which of these bulbs is getting maximum current? Yes, I've seen all your answers. So in this particular circuit, total current is flowing. In that particular circuit, in the original circuit, total current is flowing. That is I, because it is in series. Correct? But here in parallel we know current divides. So this current will be something I1 and this will be I2, which will definitely be less than I. Correct? So this whole circuit cancels out. This whole circuit is not in the play. This won't get enough heating, and then it won't glow that much, it won't have that much brightness. So the option is, and now 1 and 5 are in series, so they will get get equal amount of current, and hence they will glow the brightest. Okay, yes, everyone was correct. Hi, Bunty Kushwaha is saying hello ma'am, I'm back, but it's fine. We have started, we have just reached question number 6. We revised it through mind map, so you can go check that out. Okay, 7th question. The current flowing through a resistor connected in a circuit and the potential difference developed across its ends are as shown in the diagram by milliammeter and voltmeter readings respectively. They have asked us what are the least count of these meters. Let me know what are the least count of these meters. Hi Ankit, ABCD. Hello Ishrat Jan. Okay, let me know if you can solve this. If you can solve this question. Do you know how to solve this question? We are given a particular diagram or a particular picture of a milliammeter and a voltmeter. This is milliammeter and a voltmeter. Now they have asked us the least count of these. Yes, I know Vikas, your name, I remember. Vikas. Okay, let's solve this question. For this particular question, for least count, you have to look at the two consecutive readings, correct? So this is 100 and 200. So for least count, how do you find least count? Least count is nothing but the difference of two main readings, that is 200 minus 100 and the number of divisions between them. So in between them we have 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Correct? We have 10 divisions between one particular main division, that is 200 and 100. So this is how you find the least count. So this will be 100 divided by 10, that will be 10. Now, but this least count is for milliampere. Okay, this is a milliammeter. Yes, okay. The least count for ammeter will be 10 and the least count for voltmeter will be what? This is for voltmeter, this is for ammeter. For voltmeter, two divisions are 2 minus 1 and the divisions are again 10. So this will be 0.1. Remember, this is for milliampere and this is for volt. Okay. Hi everyone, it's fine. Hello Meena. Hi, it's fine Meena. Hi everyone. Okay, understood. Least count for these 2 meters. We have understood. Now they have asked us what is the resistance of the resistor. Now we are given voltage and we are given current. So we can easily find the resistances. Correct? But we need to see what is the exact value of current and voltage here. Okay? So let's just see that. Now when you see this is current. So current will be since the needle is pointing here at this point, correct? So this will be 200. 200 is the given. We can clearly see plus. Now these are 1, 2, 3, 4, 5 divisions. 5 divisions into the least count. Least count was 10. So into 50, this will be 250, but it's milliampere, not just ampere. Take care of the units. It's milliampere and voltage will be again 2 is given. We can clearly see 2 plus. Now clearly see the division, it is pointing at this one, correct? So 1, 2, 3, 4. 4 into least count. Least count was of voltmeter now is 0.1. So 2 plus 0.4, that will be 2.4. Correct? Now R will simply be V divided by I. V is nothing but 2.4 volt and this is 250 but it's milliampere. So 10 raised to power minus 3 voltage by ampere. Now you can just solve this. This will be 2400 divided by 250, and if you solve this, what will you get? You will get something around, now you can solve this, right? 9.6. You will get something around 9.6. Not 9.68. Yeah. Yes. 9.6. Correct. Understood, everyone? What is 16.67? How are you getting 16.67? Yes. Everyone understood the question? Can we move on to the next one? Okay. Next question, question number 8. You have 4 resistance wires. Okay, you have 4 resistance wires of same material. Select the wire which will offer the least resistance to the flow of current in an electric circuit. We have 4 options. First wire has length 2L, diameter 2D, length L, diameter D, length L by 2, diameter D by 2, length L by 4, diameter D by 4. Do you know how to solve this question? It's very easy. Let's just look at very carefully. All these numericals that I've brought you, these are easy. These are actually very easy. But the chances of doing silly mistakes in these numericals is very high because they require patience, first of all. And you should read the question very carefully. Okay? Okay. Let's solve this. Let's solve this question. Can we? Ishrat Jan is saying B. Aksa is also saying B. Legend is saying pen and paper. Are you solving it? Okay, so we have 4 cases. Now, how you solve this question, the way you present your solution is very important. Okay, let me see if yes, I have first length as why is it not working? So we have length as, for first, length as 2L and diameter as 2D. Now I have to see if select the wire which will offer the least resistance to the flow of current in an electric circuit. Correct? So we have to see the resistance. Now, so we simply know the formula of resistance is R equals to rho L by A. Now A is area of cross section. For that we need radius. So the radius of this will be D. Correct? The diameter, radius is half of the diameter. So we can just write, for first the resistance will be pi into D square. So for first R1 will be rho L by pi D square. Correct? This is the resistance due to option A. Now due to option B, we have length as L, diameter as D. To find the resistance, that will be simply rho L divided by. Now resistance will be radius will be D by 2 here. That will be pi into D by 2 square. Correct? Rho L divided by pi into D square into 4. Correct? R2. So R2 will be 4 rho L by pi D square. Correct? This is my R2. Let's Kemal is saying option D, Legend is saying option A, Meenakshi is saying also saying option A. Let's check who of you is correct. Okay. I can't change this slide. Yep. So option C, the C part, according to the C part, we have length L by 2, diameter D by 2. So length is L by 2, diameter is D by 2, and hence radius will be what? Half of this, that will be D by 4. Correct? So resistance will be rho L by 2 divided by pi D square by 4 square. Correct? And this will then be rho L by D square. We will separate this term out. This whole will be, this will go there, 64 divided by 2, which will be 32. Correct? Sorry, 16. Oh, my bad. I just wrote 64 as the square of 4. Okay, 16 divided by 2, which will be 8. That will be 8 rho L by pi D square for R3. Correct? Then for option D, we have L as L by 4 and D as D by 4. And radius will be D by 8. Correct? So resistance will be rho L by 4 divided by pi D square by 8 square. Now 8 square will actually be 64. So 64 divided by 4 rho L by pi D square. Correct? And this will be then 16. So this will be 16 rho L by pi D square. This will be R4. So R1, R2, R3, R4 we have, and the biggest value is what? We need to find least resistance. So least resistance is the first one, that is simply rho L by D square. So A is the correct option. Everyone who said A, Legend, Meenakshi, you are correct. Aksa also said Aksa said B. Okay, everyone understood. Let's move on to the next question. 9th question, it says that calculate, consider the following circuit. In which circuit will the power dissipated in the circuit will be minimum? The power will be minimum. Now, we have these resistances. We'll simply see in which the power dissipated is minimum. Okay? Do you understand? Okay, Kajal is saying A. Death. Sorry, ma'am, I'm unable to do it. Okay, it's fine. Okay, Reena is saying A. Is this for this question or the other one? Last question. For last question, the answer is A. Actually, very good. Everyone is correct. Okay, let's move on to this question. So we need to see power dissipated. We'll simply have, we have V, we have resistance. We'll use the formula of power, which includes potential difference and resistance. That is P1 as V square divided by R. Correct? So V square is 12 square divided by 5. You don't have to solve it completely, just look. Okay, so in here the equivalent resistance is 10, so V square, V is same, 12 square divided by 10, and in here it's parallel, so this will be 5 by 2 total resistance. Correct? So power will be 12 square divided by 5, 2.5. Correct? Now you can clearly see that the minimum power circuit will be minimum is circuit second, that is the option is second. Correct? Now if you don't have to solve it, we clearly know that the formula for power is, why is it not working? Formula of power is V square divided by R. Correct? So we need power as minimum. If power should be minimum, R will be maximum. And in which case, simple, series or parallel, R is maximum. In case of series, ma'am, we know very well. Correct? So the correct option is second. You can do it without even solving the question. Okay? 10th question says an assertion reason, very easy question. And yes, Vikas is also saying B. Meenakshi said B. Okay, so V square by R, very good. Now moving on to the question number 10th. Assertion is saying the commercial unit of electrical energy is kilowatt hour. It is kilowatt hour for electric energy. The commercial unit is kilowatt hour. Reason they are giving is 1 kilowatt hour equals to 10 raised to power 6 joule. Hi Prince. Is this correct? Are both statements correct, or they are false? Are there correct explanation? What is it? Okay, so if you look at the assertion, Death Gamer is saying B, Prince is saying A. Okay, B. Sorry ma'am, it is B. R true, but R is not the okay. Actually, let's see. Assertion is correct. Electric energy, the commercial unit is kilowatt hour. But 1 kilowatt hour is actually equal to 3.6 into 10 raised to power 6 joule. Isn't it? Isn't it 3.6 10 raised to power 6 joule rather than just 10 raised to power 6? Let me know. Right? Correct? Yes. So the answer is actually C. Answer is actually C. Assertion A is true, but reason R is false. Okay. Now, 11th question says, plastic insulation surrounds a wire having diameter D and length L as shown above. A decrease in the resistance of the wire should be produced by an increase in what? By an increase in length of the wire, diameter of the wire, temperature of the wire, thickness of the plastic insulation. Yes. Let me know the answer to this. Preeti is saying C, temperature of the wire. Meenakshi is saying B. Okay. Is it for the previous or the new one? Okay. So we have a plastic insulation and they have simply asked us a decrease in resistance of the wire. So resistance is generally given by rho L by A. Now rho will remain same. Now either I can, now we have decrease in resistance. We want the resistance to decrease, correct? So either I can decrease the length or increase the area or diameter or radius, correct? So which of these options is true? Since it is plastically insulated, so temperature won't play any role. Thickness of plastic insulation won't play any role in the resistance, correct? So this is also not true. Length of the wire, if they are asked, would be produced by an increase in. So if we increased the length, resistance will increase rather than decreasing. So this is also not true. The correct option is diameter of the wire. If we increase the diameter of the wire, the resistance will decrease. Resistance is inversely proportional to area. Very good. Samji, am I pronouncing your name right? Okay. Okay, let's move on to the next question. Again, one more assertion reason question. It says, assertion says, nichrome is an alloy commonly used in electrical heating devices such as electric irons, toasters, etc. Reason said the resistivity of nichrome is very high and its resistance decreases with increase in temperature. Is this true or not? Legend is saying B. Yes, for the last question, yes. Is my internet lagging a bit? Nope. Okay, so in Meenakshi is saying C, which is A is true, but R is false. Anyone else? Let's see. I want you guys to answer this. Can you answer this properly? Meenakshi, what? Okay, answer this question, everyone. So you're saying assertion is true, but this reason is false. Okay, everyone is correct. Actually, the nichrome wire is definitely an alloy and it's commonly used for heating devices, but the resistivity of nichrome is high. This is correct. And its resistance decreases with increase in temperature. That is not correct. Its resistance does not decrease with increase in temperature. So assertion is true, reason is false. Correct? 13th question. The minimum number of identical bulbs of rating 4 volt and 6 watt that can work safely with the desired brightness when connected in series with a 240 volt main supply, then how many bulbs can be connected? C, yes, legend, you were correct. Death Gamer, Samaji, everyone is correct. Now, how many bulbs of 60 watt of 4 volt can be connected in series when the total supply is 240 volt? Okay, if you see this question, this is very simple. All you need to know that the bulbs are connected in series. These are series, okay? These are bulbs. One and same thing, okay? So if 3 bulbs are connecting and the total supply is 240 volt, correct? Now if 3 bulbs are connected, current remains same in all these 3 as they are in series, but voltage divides. Now voltage divides according to since their resistance is same, as their power is same, they are of same voltage, so they have same resistance, and due to their same equal resistance, the voltage will be distributed equally between them. So if 3 bulbs are connected, so 240 divided by, we have minimum number of identical bulbs. Okay, so if 3 bulbs are connected, in each of these bulbs the resistance will get 80 volt, 80 volt, 80 volt. Correct? But here we have each bulb does not have 80 volt but 4 volt. So each bulb has 4 volt voltage. Total is 240. So how many bulbs of 4 volt should be connected so that they can be easily powered by 240 volt? That is very simple. Let's say n bulbs are there. Each has 4 volt potential difference and the voltage we are getting is 240. So n will simply be 240 divided by 4, that will be 60. Correct? So the option C is correct. 60 bulbs should be connected in series so that they can work properly with a voltage of 240 volt. 60 C. Everyone said C. Very good, very proud of you, all of you. Okay, next question number 14th. It says 4 wires of equal length and of resistance 15 ohms forming a square. The equivalent resistance between 2 opposite ends of the square will be what? Let me know. Let me know if you know how to solve this question. Okay, so we have 4 wires of equal length and of resistance 15 ohms forming a square. This is basically what is given in my question. Correct? This is what is given in the question. The equivalent resistance between 2 opposite ends of the square. So let's say between this and this we want to find the resistance, and let's say there is this battery. Correct? This has 15 ohm, 15 ohm. So these two are in series. Correct? And these two are also in series. Perfect. So we can just add them. Where are you from? Hi, I am from Punjab actually. Can you solve these questions? Now you have this important information. Okay, Meenakshi is saying 15 ohm. Okay, let's see. So the upper circuit. This upper circuit will have series connections, so 15 plus 15, 30. This lower one again will be same, 15 plus 15 are in series, so the equivalent will be 30 ohm. But these two together are in parallel with each other, so this will be 1 by 30 plus 1 by 30, that will be 2 by 30, that will be 1 by 15, but this is 1 by R equivalent, so R equivalent will be 15 ohm, and Meenakshi was correct. Very good, Meenakshi. Correct. Sudesh Kumar is also saying B. Oh, Sudesh Kumar is saying he's from Haryana. Hi, neighbor. Okay, everyone said B. Ma'am, my name is Sridhar. Okay. Hi, Sridhar. Okay. A lot of you are saying B. That is very good. Very good. I'm so proud of you guys. Okay, let's move on to the next question. We just have 1 or 2 more questions left, I guess. 4 identical resistors. Now, I have brought you so many questions. I want you to go like this session right now. Hi. Sudesh Kumar. Oh yes, hi. So I want you to like this session right now. I brought you so many numericals and you're going to ace these boards. So go like this session. So we have 4 identical resistors, each of 8 ohm, each of resistors 8 ohm. They are first connected in series, okay, with resulting resistance as Rs. Then they are connected in parallel with resulting resistance as Rp. Find the ratio of Rs by Rp. We have an answer. It is C. Answer as C. One is saying D. Sridhar is saying D. Okay. Let's see which of one of you is correct. Okay. For RS, let's see. For RS and Rp, we have 4 identical resistors. So RS will be R1 plus R2 plus R3 plus R4. But if you are Syana Bacha, something we say in Punjabi or something, I guess, so you'll just use N into R since the resistances are same. So we have 4 resistances and the resistance is 8 ohm. 4 into 8, that will be 32 ohm. Correct? This is the equivalent resistance when these are connected in series. Okay? Then for Rp, we'll simply use a clever formula which is N by R. That is what? How many did we have? 4 divided by 8. Correct? That is 1 by 2. This is 1 by Rp. Yes. So Rp is what? Rp is 2 ohm. Now we need the ratio of Rs by Rp. So Rs is by Rp will be what? Rs is 32 ohm, correct? And Rp is 2 ohm. So 16 will be the answer. Whoever had given 16 was correct. 16 is the correct answer. That is option number C. Ma'am, it is 16. I did calculations. Okay, Sridhar. No worries. Okay, so answer is actually 16. Yeah. Fine. Okay. Done. Move on to the next question. I guess this is the last question. Oof. This is the last question and I want you to read it carefully and I want you to totally solve it. Okay. What is the... Okay. Study the IV graph. We are given a graph with 3 resistances R1, R2 and R3 and select the correct statement from the following. Okay. They are given either R1 equals to R2 equals to R3, R1 greater than R2 greater than R3, R3 greater than R2 greater than R1, R2 greater than R3 greater than R1. Let me just clarify this. This is R1, this is R2, and this is R3. Now give me the answer. Answers are, oh, legend is saying very easy. C, C, C. Everyone is saying the answer as C. C, R3 greater. Correct. All of you are correct. I'm so proud of you. Since we according in general, the slope, more will be the value. But this is IV graph. If the graph was V and I, then the answer will be R1 greater than R2 greater than R1, R3, since the R is V by I. Correct? But here the slope is not V by I, it's I by V. So this is 1 by R. And since it's reciprocal, the value of R1 will not be more than R3, value of R3 will be more than R1. So C option is definitely correct. All of you did great. Hello, Ayanusmani. Sorry if I'm pronouncing your name wrong. And this is it for this live session. Follow our WhatsApp channel. Go join the WhatsApp channel. You will get all the notifications about the live, about the chapters, about the things we have bringing you for this GOAT series that will make you a topper in your class 10th boards. It is very important that you go and join this channel. You will get all your doubts solved, all your queries resolved, and subscribe this channel. And before going like this session, I am very serious. Okay, like this session, as we are bringing more sessions for you, there will be a live today evening by Tanvi Ma'am for SST as well. Make sure to join that as well. And be ready to ace your boards, because we are coming like almost every day. We are coming live every day for you guys so that you can revise all your work, and we are bringing tons of questions for you. So make sure you join the WhatsApp channel, subscribe the YouTube channel so that you don't miss anything. Okay, till then, tada bye bye. I'll meet you in the next live.